Okay, so let's start. So today what we are going to do, we are going to use the LSTM, whatever we have read it till now, and by using that LSTM, what we are trying to do today, we will try to predict the characters. Characters as mean, let's suppose someone has written like this, this highlighted one. Sing a song of sixpence, PENC, and it should predict this character E, right? And if suppose someone has written it like this, a pocket full of R, so it should predict Y and then E. So how it can do that? So this one I had shared with you guys, okay? And actually, so I have taken this data or this problem, the how it has solved is from one of the very famous website, Machine Learning Mastery. So I used to use the code from that website. Actually, their code was pretty good to understand. You guys can also check that and use that. I'll add the link in the video description so that you can follow that website for many of the either you have a problem with the machine learning, LSTM text, the time series, or the computer vision. For many problems, it has actually given the very optimal and the best solutions. Okay, so simply here it has saved with the text in a text file rhyme.txt. So we are going to just predict the next character. That's it. Okay, so this has saved. Now the first thing which we will open is here, prepare the data. So this data looks like this. Sorry, 1 second. Just a minute. So this data look like this, but we will not fade into this way. You can, okay, I'll share the code as well. No issues. Okay, sure. Let me do that. So you guys can use this. Okay. So accordingly, I'll share one by one as we will proceed. Okay. So this is the data we have, but this data cannot be get fed in this manner to the model. We need to do some uh, we need to make the changes in the structure of the this text or the data. It depends on the requirement, what requirement we have. So we must have to clear with the requirement. Once we are clear with the requirement, accordingly we have to change the data or to handle the data. So I already told you the requirement. We need to predict the next character. Okay, now so this is the now let's see. So the first is we will use this file or the code, prepare data. How would we prepare the data? So this is the function I'm using completely Python functions. Okay, so in that what I'm trying to do, this is the way to read the file. So its file name will be the path of the file wherever the text file is at, that data which I had shared with you. And then I'm reading that file and storing into this variable text. And then this is a good practice. Once you open any file, close it once your work is done, and then I'm returning that text. So hope this is clear to everyone, right? Now, what I'm trying to do here in this function, I'm passing two things, lines and the file name. Now, what is lines here? So let's come to here. So once we used this function load doc, it has returned the text here. And now that text I'm splitting. So split is a function which will split your entire text. If you use split, by default it will split and make the text into a list on basis of the space. So let me just print here tokens, so that, and here it is the raw text, and rest all let me comment this. Okay, and now let me run. So how to run it from the terminal? I think you guys are clear. So you have to write Python space the file name. So file name is 18. Yeah, it should be. Okay. So if suppose you have to run a Python file from a command line, so what you have to do? First, you have to go to the terminal, and in terminal you have to go to that path where your Python file is there. So let me open the terminal. So it's a Visual Studio Code. So I'll open the terminal, and here see. So if I'll do ls here, currently my this file, this one if you are seeing is prepare data. No, this is a VS Code IDE. This is like a Jupyter notebook. You have the PyCharm and the VS Code. So VS Code is widely used in the industry. Okay. Also Jupyter notebook also you can use. There won't be any issues with that. Okay. Now, so first I need to. So where is this location? So it is actually, if you'll see here, in NLP mastery, then code, then chapter 18, it is there. So currently I'm in NLP mastery. So I'll have to go with the this in this location code. And now if I'll do ls here, so there are multiple chapters are looking. So this is inside a chapter 18. So I have to move with chapter 18. So I'm just using cd. Cd is the change directory. Oh, sorry. I had moved in the chapter 4. So cd chapter, and then if you use tab, it will come like this: 6, 6, 7, 8, whatever the path will available. 17, 18. So now I'm in chapter 18 folder, and when I will do ls, now it will tell you whatever the file is available. So my file is available here. You can see prepare data.py. Now if I have to run that file, I have to write Python space and that file name. So this file name is prepare data.py, and now let's enter. So when I did enter, first thing what I have printed here, raw text. See that this was the raw text as it is in our file. So we have printed this here till here. Okay, is that clear? Now I'm printing the tokens once I split it. So you can see this entire thing got splitted in a list with word by word. So that is what the work of split. Is it clear? And see, till here it is clear. Now what I'm doing here, I'm simply joining all the tokens. Though the both steps are same, this is not that was not required. I'm trying because if sometimes it happens because of some other spaces or special characters. Now here I'm trying to join those all again, if you will see, on basis of spaces. So again, if I will print here raw text, but these all will not come in a new line, because here what I have done it, I'll show where it was exactly. Save doc. Okay, in a save doc it is. So now let me save this and run this again. So I'm running this again. See this. This is my raw text. It was coming like, oh sorry. Let me clear this and run this file. See, this was the raw text here on top, and this is when I splitted it, and this is when I join this on basis of space. So this has come as like an in one line kind of. Okay, it is coming line by line, not like this. Okay, so till now it is clear what I'm doing it here. Now here I'm using character, next character. So for that I'm preparing the data. Now here I'm taking length equal to 10. And what is length equal to 10? I'll come on that. And here I'm just creating a new variable sequence, which is a list. So you can create a list like this or like this both is fine. And now this is very important to understand this. So what exactly I will do here, You can use any. This is just a variable name. Sequence is a list of variable name. You can use any. So I just use the namesake. Now, what I'm trying to do here, this is a range function. So what exactly the range it will do? It will actually, this I value will start with the 10 value, because this is here the length I have taken 10. Why I have taken 10? You can take different also, but why it is, you can see it here. Let me close this, print. Please mute yourself. I'm getting sound. Now, let's see. Here, what I'm trying to do, just see and you will get to know that why I have used, what is the use of this code. And I will print here a CQ sequence. Now, let's run. Hmm. Is that token was there? One second. Huh. See this. If you'll see here, first time what it has taken, 0 to 11, 0 to 11 character, and in 0 to 11 character what it came, sing a song. And then it is taking 1 to 12, ing a song, means 11 was moved to 1 point ahead, and from the 0 it moved 1 point ahead, and then ng a song o. Then see, now it has gone to the character 13 with the from 2, then character third to character fourth, then character fourth to character 15, and same way if you will see, it has reached here 10, 11, 12. So whatever the character is there now, so it has total number of, see that, 398 to 409. So it has moved in that way. It means it is going like this. So the first time it will be like sing a song. If suppose it was the data, now s it will leave and it will use ing a song song, and after that if suppose there is some space, so it will take the space, or if not a space, like songi, if it is there, so it will go like this. Next time it will take ng space a song g I n, if suppose it is like that. You can see it is taking one character from behind and then it is keep on taking the next characters. Okay, this is how it is doing. Is it clear here? No, I'm not putting anywhere. You just understand, I'm trying to prepare the data in that manner that every time it should start with the zeroth, and I'm taking only the 10 sequences. That's why this is the length. If you'll see this in every line here, the 10 sequences would be closely to that. Let me check. Oh shit. Let me check. Probably it will be 10 sequences. Eleven, maybe it is last, or it will take 11, 10, so it will 0 to 10. Okay, 0 to 10, 11, it will be 0 to 10. Yeah, yeah, 0 to 10, so 11 it will be, I think. Ed of no, no, no. For the last, I think it was taking, otherwise it will take 10, because 0 to 11. So it will be 10, no? 0 to 11. It will be 10. It will be 10, 0 to 11. Okay, sorry, 0 to 10, correct. Sorry, my bad. So 0 to, am I doing mistake any? 0 to 11, it is total 10 characters, right? Yes. Hmm. It is passing one. We can make it here count also. Always print. We can check the length of sequence every time. So let me run this. 11 characters. Okay, correct. Every time it is taking the 11. So you can change the sequences. Okay, but just here I'm taking only a for a basic use. So that's why I have used 10 sequences. Okay. Then what I'm trying to do, let me delete these all prints. These are not required. Okay. Now here just I'm printing that the total sequences is how much, and then I'm saving this file to my one another file name as char sequences.txt. That's it. So if you'll see here in this folder, chapter 18, I have this three file, this file, and only one txt file. Once I will run this, no, you will see that it will create another file named as char sequences.txt. You can see here it has generated char sequences.txt just now. You can see and the total sequences is 399. Sequences means it has just converted into 399 lines. Now you can see here. This is the one line. So if I'll just go down here, you will see this. See this. This is still 399. You can see this index. Okay. Clear till here what this file is actually, this prepared data is doing. So here from this Python file, we are just trying to prepare the data. Is it clear? Because our requirement is to predict the next character. Okay. That is our requirement. So what I will do, I will train a model in such a manner that I will give a this much of as an x, SING, ASON, and last character G I will give it as a Y. That if you will see something like that, you have to predict the G. So it will understand the sequence like that. You can see how it will understand. First it will take SING a song, then it will take ING SONG. So it will understand that how to move ahead. Now see, one because here there isn't some space, that's why you are not seeing anything here. See that, and now it is seeing ng. So every time it will understand that after the song I have to give a space, then I have to write o, then when I have to then o, then it is f off, then it is space off, after that you have to give a space. So this is the how I'm preparing the data, so that it will understand that what should be the next character. Okay. See what I'm trying to do, I'll give my model like this: sing a song, SON, and then I'll say to predict G. Now I will say ING A SONG and to predict space. So now you understand, your model will get to know that after SON I have to understand the G, and when I will get this word song, then after I have to make it a space. The same way you can understand like this. If you have like this, then after that space you have to write O. So this is how I'm trying to prepare the data. Is it somehow better? You understood that what exactly we are trying? Okay. So now this is here we prepared the data and saved in one text file named as char sequences.txt file. Now let's come to the model training. So these are the files needed. So plot model I'm not using here. I think it has deprecated. So here I'm using this. Now let's see. Here again, load doc. So what it will load? It will load our new file which we have saved, char sequences. Now here we are defining the model. So LSTM. Okay. So there are three things which we need to understand first: sequential, dense, and LSTM. What is the use of sequential? So this is a keras is actually a class. In that class, sequential is a method. Okay, method means as a function. Now, what sequential actually does, it provides the structure in such a manner that if you will write anything, okay, like in that, so this you can see it here, this documentation. Here it has written model equal to tf.keras.sequential, and in that model object, if you write anything dot add, it will keep on adding the hidden layers in your architecture. Like how would I haven't connected my this 1 second. I need to connect to it. Okay. So sequential, let me try to explain it like this. So here this is a sequence model is this sequential object. Okay. And in that object, now I'm adding a new layer named as LSTM layer. And then after I'm adding a dense layer. So what is LSTM layer and what is dense layer? Just allow me a minute. I'm not able to pause this. Just give me a minute. Just give me a minute, okay? I'm connecting my board and then I'll explain. Okay. So you can see my screen, right? Okay. So what exactly? So when let's suppose I'm writing here model equal to sequential. So this is just understand an object. So it create an object. Understand in a hypothetical way. it will just create a box. It will just create a box. And now in that box, if I will add something, it will add as a layer. So if I will write here model dot add LSTM. So it will add one LSTM layer into that object or that box. If I will write here then model dot add dense. So it will add a dense layer, that is called. And in dense, how many neurons? So if I'll pass here 10, so there will be 10. So here 3 means I would have passed here 3. Okay, so the output will go. Sequential means whatever you will write in a sequence, that it will get added here in a sequence. Okay. And what is this LSTM? That what we read it in our last class. So do you understand that what exactly that sequential means and what it is doing? Yes. So once you'll start, it will be continuous. You can add whatever you want, the parameters or the objects you want or the layers you want to add. Now here we have created a sequential object, and in that object I'm adding a LSTM layer with the value 75. Now do you understand what exactly the meaning of 75? If you remember, when I was explaining the LSTM, that if you'll pass the unit 75, so that whatever the neural networks available in the LSTM, either with the sigmoid or with the 10H, those all will have this much of the neuron, and the size of H in 70 in forget gate, in input gate, and in the output gate. There were 3 neural networks. Let me show it again here. If you'll see LSTM, the image, you'll see that here. This is neural network. This is, and this is. So these all have the 75, 75, 75 neurons. Yeah, I can hear you. Okay. So this is how. Now let's go ahead. So this is, and now LSTM. So I was saying that when we are passing here the LSTM layers in that 75 unit, that 75 unit means whatever the neural network which LSTM has, that all neural network has the 75 number of neurons. 75 units means 75 neurons. These all. Okay. So that what's the, sorry, you can take any, that is up to you. If you want 20, you can take. So higher the number, better the performance. It will take more computational power. It will take more time to get trained. Okay. Now LSTM always expect data should be in the 3D, in the 3 dimension. Okay. Data should be in 3 dimension. 3 dimension structurally way, if you'll see, this is actually kind of uh, if you are passing it here like this is kind of 3 dimension. So I'll come that what exactly, I'll show the data that how exactly the 3 dimension, and why I'm egg shape 1 and egg shape 2 I'm giving. I'll come on that also. For now, just understand. And then after this one here, I'm adding dense layer, and then I'm writing here vocab size. Now what is vocab size? So let's understand this architecture here properly. So the first, we have this LSTM layer. Okay. Now after that LSTM layer, I'm trying to add the dense layer here. So neurons. So now the question is, How would I decide that in output layer how many neurons should be? So this is my output layer because this is the final layer. So how many neurons should be? See, in a hidden layer, you can pass any number of neurons. That is not going to be the concern. But in output layer and in input layer, the number of neurons should have the criteria or should have some calculations. It has calculations. So how many neurons should be here in this scenario? So let us suppose I have a text here. I have a text, some lines of text, and my task is to predict the next character, to predict the next character. So if suppose I have given an input here, sing a son, and what it should predict here, G, right? Sing a song, sing a son, and it should predict here G. Now what I will do with this network, first I will try to extract all the unique characters from this text. Whatever in your text, whatever the unique character is there, just count, and that is your vocab size. Vocab size. So let's suppose, just hypothetically, in this scenario, there is total 8. So 8, if suppose, so 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now 1, 2, 3, 4, 5, 6, 7, 8. Total 8 neurons are there here. And let's suppose you entered here sing a song, SON. So as you entered here sing a song, now what could be the scenario? In total 8 characters, let's suppose this is for the A, this is for the M. I'm just taking randomly. This is for the G, this is for the K, this is for the L, this is for the space, this is for the O, and this is for the P. Now once you will give this input, what will happen? For this every neuron, it will give you some probability, like maybe 0.2, and this entire probability sum 0.1, whatever this entire probability sum will be equal to 1. And whichever characters, for whichever character the probability will be higher, let's suppose just for this scenario, for this it is 0.6 for the G, so it will give you output as a G. Okay, but let us suppose for this scenario, for one scenario, it has given for the L, it has given 0.6 as the highest, or maybe 0.7, but it should not, because 0.6 and 7 will cross 1. But understand this 0.6 is not there, and for the for the L, it has given 0.7 as a probability. Now it will check that for this input I am getting the highest output from the model is L, but my actual output is G. So what it will happen, it will calculate the loss here, that what is the loss and how to calculate the loss. If you remember, or if you not, I will if you don't know, that I'll cover. That is something called cross entropy loss. Cross entropy loss. So it will calculate the cross entropy loss, and it will do the back propagation. Back propagation means it will try to tune, it will try to change the parameters, weight and the biases of your neural network and of your LSTM, and it will try to minimize this loss. And when the loss will get minimized, when the probability of G will be higher, or we can say in another way, when this model will give you the output as a G, then output as a G also, and the actual is also G. In that case, the loss will be minimal. So this is how it will keep on working. Then first sentence, then the second sentence, then third sentence, then fourth sentence. It will keep on going. Understand? So this is how. So that's why we are using a softmax function. So what exactly the softmax do? Just let me explain. Softmax. So softmax. Let's suppose you have a five classes, like uh, just for this scenario, five characters like A, B, C, and D. So what it will do? If suppose you have to calculate the probability of A, so e to the power A, whatever the value it will come, the for value of A, whatever it is, e to the power A plus e to the power B plus e to the power C plus e to the power D, like that. So this is the way the softmax calculate for every, okay, and whichever is having the maximum, it will give that as an output. So that's why if you have always, if you have ever a multi-class classification problem, means more than two classes, because here in that case we need to predict the multiple characters. So that's why we use softmax. And which loss I already told, if you have a multi-class, so you have to use categorical cross entropy. Now optimizer. So what is the work of optimizer? The work of optimizer is, suppose when I said it here, no, that it will go as a back propagation, and it will try to minimize your weight and bias. It will try to minimize your weight and bias. So to reduce the weight, minimize the loss by tuning the weight and the bias, there are multiple ways. Okay, there is a concept called global minima and the local minima. I mean, just understand, to reach this point, from, if suppose some person is here, this is one person, and this point is the minima point, and this person wants to reach this point, this minima point. This person wants to reach this minima point. So some person will, sometimes people will go like this, travel like this, and then it reach here. Sometimes people travel like this, sometimes people travel like this. So understand an optimizer in that way, that it will give you a optimal path, or it will give you the shortest path, or it will give you a path which takes the minimal time to reach the minima. Minima means having the minimum error. That is what the optimizer is. And they use some different formula to achieve in a less time with the shortest path. Okay. So in that there are multiple optimizers. So currently I'm using Adam. Apart from that, there is an AdaGrad, RMS Prop, SGD. So on that, sometimes we will discuss. So then we are compiling the model, and accuracy we are using the metrics that we want, that sometimes it depends that what you want, error like RMSE or MSE, but usually in a classification problem we will use the accuracy. Okay, sometimes people use precision, recall, or other things, but right now we are using accuracy here. And model dot summary just print you or give you the entire summary, that how many trainable, non-trainable parameters are there in your model, and then this function is returning this model. That's it. Now whatever we have written here, two functions, okay, the two functions we have written here, loading the document and defining the model, these all two we will call it here. Now see, this is our file name, char sequence.txt, which we have saved it. Okay, by using the load doc functions we are loading that, and it will get stored here in .txt. And then what I'm doing here, I'm splitting that in a lines, like on basis of the new line I'm changing. That's it. See, if you want, I can print here and I'll show. So it will exactly say nothing to like more. See that print raw text, and what I will do, I will for as a marker, I will just use some line here. Okay, and then let me print the lines here also, and let's see what exactly it is printing. Let me put all those things here commented. Okay, now let me print to use this train. Okay, See that. So the first, what I am doing here, I'm printing the raw text. So if you remember, we converted this in the this way, 399 lines. So this is how it has. Now you can see this is the line which I gives a separator, and then what we are trying to do, we are splitting on basis of new line. So this is the new line. This after this is one line, this is one line, and we are storing in a list. That's it. Sing a song, and then the next line is a this one, then the next line is a this one, next line is a this one. Like that we are trying to do. Okay. Now here in the next line, this one, what I'm trying to do, what I said, I will extract all the unique characters. See that what I'm doing from raw text. This is from the raw text, whatever we have read it from that file, I'm passing into a set. So set is a data type or the data structure in Python. What it do, it will only keep the unique things. So for an example, in a set of a list, or not, if a set is a value 1 2 3 1 2 7, and if I will run this, oh, sorry, it will be just like this. So set in a curly brace. See that I have written 1 2 3 1 2 7. You can see it has 1 2 3 and 7. This 1 and 2 are the duplicate, it had automatically removed that. So the same way, if I will pass a character like A, B, again A, and C, and let me run, see that because this A was coming two times, and C, it has removed. Please mute yourself, I'm getting some sound. So you can see here it has removed this A. So that what exactly we are trying to do here. So in that case, we are simply, let me print that, and let me this one to just, let me know if you will not understand. Just tell me that you are not getting this or what. See, it will tell you. See, these are the total unique characters available. New line, space, inverted comma, then full stop, then semicolon, A, B, C, D, E, F, G, H, S, T, whatever it is. Okay, these are the unique characters. Correct? Now, what I'm trying to do here, understand. Then after, I'm trying to do mapping. So what exactly mapping do? Here mapping, I'm trying to create a dictionary, and for every character I'm trying to assign some integer value. So enumerate is a function which used to do this. So how enumerate works, let's suppose you have a value like this 10 20 30 40 and 50, and if I will write like this, for I in NUMERT enumerate of L, and then if I will print I, see with the index 0 1 2 3 4 and this value it will give. So exactly I'm trying to do the same for I and C. I is the index, C is the character. From the chars is what, your unique, this characters. So for every unique characters I'm trying to add some integer value. Let's see that. See, this slash n as 0, this space is 1, this inverted apostrophe s is 2, this comma is 3, full stop is 4, like that. And why I'm trying to do that, because we know that model or the algorithm won't understand characters or the text, it understand only the numbers. Now here what I'm trying to do, I'm just trying to create the list. Okay, and let me clear it till here. So this is a list. You can make it like this also. So if you remember these lines, This lines, what I have done it here, we stored in a list all the lines in a list, right? So let me better to show you here, so you will understand it in more better in Jupyter Notebook. Okay, now this is print raw text. See that this is the raw text, we are reading it from the file. This is clear. Now that raw text I'm splitting on basis of line, and I'm just showing you the 5 lines. See that it will go like this. It will print this entire, like, see, sing a song, ing a song, like this. This sing a song will be the first, and ing a song is the second, and so on. Then I'm trying to take the unique characters, converting into a list and sorting it. See that it will be like this. And then here I'm just trying to give the index value or a number to every character. Now what is lines here? Lines, you can see this is. So when I'll do for line in line, so the first time it will take this value. See, line. And now in that line, I'm again using a for loop. Now I'm taking the first character of this line. Like I'm taking this S, the first character. And from mapping, so just understand. If suppose mapping is what? It's a dictionary. Okay, if you'll just check the type dictionary, if you guys do remember that how dictionary works. So in dictionary, let us suppose if I will pass here a, can anyone tell me what output it will give? In this mapping, if I'll pass a, what output it will give? It will give you the value of a. A is a key and its value is 6. So see that it has given a 6. Same way, when I'm doing here, let me break it for you guys. For line in lines, print line. So I'm just making a break to print only the first line. See, sing a song. Now after that, what I'm trying to do, see, then for char character in anything you can take, for character in line, print char, and then I'm just doing break here. See this. Now earlier it was one line. Now on that line again I'm using a loop to print exact character. Now in spite of printing the character only, I will use this mapping and I will pass this character in that, because I have taken all the unique keyword from that. Now see, for the S it will be 12, I 23, N 27, G 21, space is 1. You can see that space is 1. These all have taken it from here. The same I am doing. So that is called, I'm trying to encode that. And those all encoding I'm just saving into a new list. That's it. So you can see here, this list will look like this. So this is your first sentence now looking like this. And this is your second sentence, and so on. If you want to see just like 5 sentences, see that. It will be. It is like this. Clear? And if you'll print the sequences, which I just to show it, you can, I mean, if I'll print this complete sequences, no, here, the 399 will come like this. So just to make you guys easier to see. No, this will be the 399. No, unique are the characters. So on base on every characters from a sentence. So this is a representation of sing a song for this line. I'll show for the, see, for the lines 0. Correct. Yes, correct. You just see this one, this first. I will, yes. If you see it here, for this, I'm saying this is the encoded. How? For the S character, you can check the dictionary. If you will check this dictionary, for the S character, what exactly it is? 12. See that here 12. So that's what I did. For every line I took, and from that line on every character I encoded the value which I prepared in a mapping dictionary. Understand? So for the 399 lines, now we have a 399 encoded sequences. And this mapping, the length of the mapping is your vocab size. Length of mapping means unique your characters. So how many unique characters available? 38. Okay. Now I'm just trying to convert this into a numpy array. So you can say it came 11. Now why it is coming 11? If you remember, when we were creating this data, and in every line we were having the 11 characters, right? Yes. So that's why here I'm taking it when I'm converted into a array, it becomes so it will look like this. Uh, you can see now this sequences. If I will do, see that in every line here you will see this is. So this is the entire sentence, and every uh, character is a, just understand, 11 character is a time stamp now. So this 11 which you are seeing, this is called the time stamp of the LSTM. If you remember when I was explaining the LSTM, that this the first word will go, then second word will go, then third word will go. So yes, the first we were passing xt. So for the xt, and then xt plus 1, xt plus 2, or xt minus 1, xt minus 2, xt minus 3. So like this, here it will go xt or xt minus 1, this is xt minus 2, xt minus 3, xt minus 4, xt minus 5, xt minus 6, xt minus 7, and then what should be the next? Okay. Now we have the 11 number in every line. So understand this 11 number as a character. So right now I will refer it as an 11 number, 11 numbers. You will understand whenever I'm saying number 11 number, that means 11 character. So what, so it will happen that in my model I will pass only the 10 numbers, and I will ask my model to predict the 11 number. Means I'm passing the 10 characters every time and asking my model to predict the 11th character. Correct? So for this sequence, what I will do, so this is the way to slice a two-dimensional sequences or two-dimensional array. So before the comma, I'm taking all the row. So this column means I'm taking all the row, comma, I'm taking all the columns apart from the last column. -1 means apart from the, so you see, this is 399 by 10, and how much we had? 399 by 11. So you can see this 399 by 10 I'm putting in a x, and the 3 and the last one I'm putting in a y. So you can check the shape of the x dot shape here, 399 by 10, and you can check the shape of it is 399. 399 by 1 means the last only record. So I will just show you y y of 0. So y of 0 is 21. See that this value, and y of 1 will be definitely 1, and y of -1 will be definitely 4. So you can check this 4. Understand how it got prepared? -1 will take it from the lower sides, from the back side. So this is the -1, this is -2, this is -3, this is -4, -5, like that. So this top start, see, indexing starts with from the both side. From the left side it start with the 0, and from the right side it start with the -1. So you can use any. Yeah, let me give you. So if suppose this is 10, 20, 30, and 40. Okay. So if I will write here L of 0, that will be 10. But if I will write here L of -1, it will be 40. So from this side it start with the minus. -1, -2, -3, -4. And from this side, it start with 0, 1, 2, 3. Okay.
So the 4 will be 5.
This 4.
No, not 5.
Oh, here you are saying
No, no, above only.
4 will be 5. Understand it here. See, if I will write here, okay. In this one you want, okay. So this is your sequence, and see this comma, before the comma whatever you will write, that will be for the row. After the comma, whatever you will write for the column. So here column means I want all the rows, and a column I want till 3, means I want only till 2. 0, 1, 2. See this 0, 1, 2. See this 0, 1, 2, and all the records. And if I want till 4 records, so I mean 3 records, so I will put like this 0, 1, 2, 3, and 0, 1, 2 columns. Okay. Now, so here we have prepared the our x and y. Okay. The last characters from the every line we put it as a y, and rest all except the last character from every line we kept it as an x. Now we imported one function or method which is called two categorical. So what exactly the two categorical function do? Know, just let me explain it from here. So let us suppose you have this value which is called here the value is 10, 20, 30, and 40. Okay, and here it is, and I will write here the number of classes is 4, and see what it will do. So, next this one it is saying two categorical number of classes it should. Oh, sorry. Index 10 is out of bound. X is 1 with. Okay, maybe it will go with array. Step. Index 10, why it is saying? Wait 1 second. It is like this, right? Actually, it will take array and it should go like this. Index 12. Huh, correct. So, what will happen here? What two categorical? So, let me put a smaller value 4, 3, and 5. And number of classes is 5. Let, I'll explain 1 second. 4 3 7 5 12 11 4 it will not take now. 11, okay, 6 it should take. 5 it will throw error. Okay. See what exactly I'm trying to do. Let's suppose you have this number of list of a numbers. List of number means this 435 represent your character. Okay. Now what I'm trying to do here, if you will see, this three numbers got converted into three records. See, there are three numbers. These all three numbers got converted into three records. And if you see, this record has here the value 1 and rest all values are 0. Here this is 0, this is 0. Here in the second record, this value is 1 and these all become 0. So this is called a type of encoding I'm trying to do. Okay. So we have a total 6 number of classes, 1, 2, 3, 4, 5, 6. That's I passed here. 6. So, and here number of classes I took vocab size. Vocab size is 38. So total 38 column will be get created, and in all 38 columns, wherever the index of that character will be available, no, that will become 1 and rest all will become 0. So in that scenario, let's understand here. Index means their number, at what index it is. So if you'll see here, x of 0. So x of 0 is, what is this line? 12, 23, 27, 28. Okay. And now let me run this and show it to you. So there are total, and what is the vocab size? Vocab size is 38. Okay. If you remember, vocab size is your unique characters. So this all sequence, this one will have the total 38 numbers, and in that 38 number you can see the 12. So the first time the 12th value will be 1. So 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so it will be from the 0 actually. 0 1 2 3 4 5 6 7 8 9 10 11 12. This is 1, and here 23. So if you will see this here, in that the 23th index, this one will be 1, is 1. And the same way it will happen with the entire thing. What we are trying to do, we are just try to encode that. Try to encode that in such a manner so that for every record we will pass. Now for this one, I'm just trying to convert into a multiple records. So for this 12 which we are seeing it here, no, this is just another way to embed that. So if suppose this 12 is a one character, 12 is a one character, and that 12 I am passing it as an one record. Because what I'm trying to do, in your LSTM we were passing the word, but here every time we have to pass one character, right? So the first time this one will go, length will be your vocab size, this 38. You can see it here. That's what I said. Now every character is getting represented into 38 dimension. In
So every character is passing. While the rest of the characters.
Correct. Now here just, yes, similar to monoid recording. Now here we are just, when we are trying to convert into a sequence, now see it has converted into 3D. 3D is total 399 records. If you remember, the total 399 lines were there. 10 is the every character in that line. 38 is our vocab size. Clear? Yeah, this 399, Sumitra, you remember, this was the 10 in every line, that many of the characters. 10 is a x value. Why it is? Because one character we passed into the y.
Oh, yeah, correct.
So that's why it become here 10. 38 is the unique character available in your data.
In the whole 99.
Yes, in whole 399, this 38 is the unique characters available. And from 399, I'm just showing you the shape of the first. So this is 10 by 38. Correct? And the same whatever I have done with the X, I'm doing it with the Y. That's it. Two categorical Y and the number of classes is the vocab size. Okay? Now here we are trying to now build the model. So LSTM layer sequential, once we build LSTM 25 unit, input shape is, and remember in input shape we have to pass these two things, 10 and 38. 10 is the how many time stamp. 10 is the time stamp. Why I'm saying time stamp? That every character will go one by one. So first character is the first time stamp, second is the second. So how many total time stamp? 10. So that. And this 38. So if you remember this 38, that total number of columns that created, right? So this is how. And in the dense layer, I'm passing. And how many total number of neurons should be in the dense layer, which is the output layer here? Only one dense layer I'm using. So number of vocab size. So number of vocab size is how much? 38. This is the neurons in the input. No, this is for the LSTM and this is for the dense. I explained it here. Dense is this neuron. This neuron. This one. This, yes. So that we are passing here in a softmax, and you can see here. Now let's go and see it here. This is, I explained it even. This is the compiling the model, that what loss function you want to use for the model. Categorical cross entropy, because it's a multi-class. What optimizer you want to use? So you can use multiple Adam RMS prop, and what is a matrices you want. Yeah, Adam is an optimizer, and there is an other also. There are multiple. Sometime in class we will see. I'll explain that what all different kinds of optimizers and how we can use that. In which scenario which optimizer is suitable. Okay, those all things we will see. Now let's come to here. Let me leave this hint. I'm just trying to. Okay. Okay. So here x and y we separated out. We made it here two categorical for the x, two categorical for the y, and now we are just defining the model here. Define model means here I'm just calling my model. So that I showed you in a Jupyter notebook, and then here whenever you want to train the model, you have to use model dot fit. Fit is a function, and you have to pass your x and y. Epoch, here I'm taking 100. Now what does it mean by epoch? Epoch means how many times you want to take the data and return it back. So that is called one epoch. First time when the data will get passed here, and if it will return back, that is called one epoch. Return back is back propagation. Once after calculating the loss, and it will come back by adjusting the weights and biases, that is called the one epoch. Okay. So here I'm passing 100 epochs. Okay. And verbose equals to true. There is one more thing, one concept is their batch size, which I'm not passing it here. So today I will not cover, otherwise again it's 12 a.m. And then after, once the model will get fit, I'm just saving the model in the h5 file. H5 is an Keras extension. We will come on the descriptions again that what h5 extension is. And then here I'm saving the mapping file as well. That dictionary is a model file, is a pickle file. Why? Because now understand the scenario. You build an application which can predict the next character. Okay. So if someone will give you a sentence and now you have to predict, so you have to follow the entire pipeline. First you have to convert that character into a word. How would you do? If you have the mapping file, then only you can do. No, first you'll convert that characters into the number, and that number you will encode into 100, the way we had done it in two categorical, and then we will ask your model to predict. So that's fine. I'll show you how it can be used. Let me here now. Your model file I'm saving into Keras H5 extension, because this is a TensorFlow model, Keras model, and the mapping file I'm saving is as a pickle file. Yes, yes. So now let me where it is, sorry, cd code, cd chapter 18, and now Python do that 10. Now see, now you will see the training will happen. See, epochs started the 100. Let it run and then I will show you. See, if you will see it from the beginning here, in a first epoch, the loss was 3.67, accuracy was 6% only. But you can see the loss in a second epoch has decreased and accuracy increased. You can see. Now, if you will see, I'll show you in the next class by plotting as well. And what is a 13 is coming? How come is 13? So that is depending on the batch size. That I will come. Okay, on you that what exactly. This 100 is the epoch. Now at the end, if you will see, the accuracy became 99% and loss is 0.2. Okay. And if you see here, now this two file got saved, mapping and model H5. These two files got saved. Now how we can use now generate? See that. Here I have created one function, generate sequence, which is expecting four things. Your model which you have saved, your mapping file which you have saved, sequence length, how many sequence length it should be. Seed text is just nothing but I will come that what is the seed text. N characters, at how much you want to, how many characters you want to generate. So if you would see here, I'm loading here the model file, I'm loading here the mapping file, and see in generate sequence I'm passing this line sing a song. And now let's see that what exactly it will generate. So there are three times I'm calling. King was I, hello world. Okay. Now let me run this and I will explain in next class what exactly this is. Okay. Just to see the output. Okay. So it has generated sing a song of sixpence a POC. Okay. Now let's see in this here what I it is. No, not this one. Sorry, where it is. Rhyme.txt. See this. This was the sentence, no? Line. Sing a song of sixpence. A POC. See that. A POC here it has written, and then because characters I had given that much, so that much only predicted. Now for the second sentence, king was in his counting house. Let's see. See this. The king was in his counting house. Okay. And hello world syphil blr. Now see where it is. It was nowhere. That's why it gives you the this issue. Okay, because it was not that much good trend. So there isn't one problem again will come if I will just give this. Let's see the output for this XOXO. I'm just writing anything randomly. Just let me comment this all and run for this sentence only, and let's see. Okay, so but this was not the training data, no. Hello world. That's what. So I'll tell, no. That's why the reason. Now see here, when I gave here XOXO, now see what it has done. So I will come on that why it is not able to get. So there are multiple things you can understand. The data was very less, architecture was very simpler. Okay, that's why it is not. And getting a character and predicting a character is a not, it will not capture the semantic meaning. Okay, that's what. See, okay, let's see. Let's see what it is doing. So the reason it has not understand the semantic, the reason is it will not understand. You know, seeing if will then is somehow relatable, maybe it will give. Okay, because it has already, I'm saying it is not a very simpler model we have used. Okay, so that is the reason. So now what we need to understand in that how we can improve this. So now I will give you a task to you guys. Whatever this text is there, use the same text or the other text, try to take any data from the Kaggle, and not on the character, try to predict the next word. Build the architecture, the complete pipeline, and your model should predict the next word, not the character. Not the character. You have to simply just make a little bit of the changes that you have to prepare in data preparation, and try to build some better architecture, or not on the same architecture, just to try to prepare on the same
What do you
data
mean by
even.
better architecture?
No, better means improve this one. I have used very simpler, only one LSTM layer. You might use the multiple LSTM layers. Okay.
Okay, now
Theory, theory as